So thank you guys for coming out. The talk is called Principles Behind Anthos. The purpose for doing this is I've seen so many kind of derivative presentations about Anthos. I've kind of been in the ecosystem for a long time, and so what I wanted to do is not do the exact same presentation that every single person does, which basically is, hey, here's some really cool stuff. Let me watch you see something that you've already seen before in a click demo and it's done. So my goal here is to really kind of talk much more about what are the principles behind it. So before I get started, for those of you who don't know me, my name is Mike Enzer. It's funny, I feel like I almost need to read my own bullets. I'm a little tired. So I've been with Nortel or Dev9 prior to this for about 10 years now. I've been in the industry for about 25, and I currently live in Helsinki, Finland. And I'm here on loan for a couple more days before I get to go back. All right, so for those who don't know us, Nortel, we are a global company. We are operating in roughly 11 countries, even though we have a lot of footprint you can see on the screen there. Russia, we did one project, and so it's kind of cool. It makes us look like we're a lot bigger. But you can see down at the bottom there, at the very bottom of Africa there, Botswana, we actually have projects all over, or different parts of Africa and Asia and the US, or the North American and European continents. So, kind of our history, we've been around since 1985, although that's kind of a little bit of a misnomer. We bought a company in Finland called CCC. They wrote the original web browser for the Nokia, very first Nokia phone. And then since then, or not since then, but a part of that process, they were building a whole bunch of automation for manufacturing and a whole bunch of other really neat things over there. So that pushes us back a little bit. But then if you fast forward very far ahead, you see the last line there is acquisition of Dev9. So I was one of the starting folks at Dev9. And when we were acquired last year, just about a year ago today, we got brought into their family and kind of get to help share our experiences of how we build software. So my goals today, I want to real briefly talk through Anthos. And again, I don't want this to be derivative, so I'm going to go pretty lightly over the history. Then I want to talk about 3 different tools and concepts that are kind of supporting Anthos and what makes it important and what it is. Then I'll show some demos. Originally I had 3 demos, but I only have 2, so I'm a slacker. Or actually, I sabotaged myself by trying to make things look way cooler, and I deleted stuff that was actually working, and oops. So in 2.5 hours, I was able to get almost everything back up. Anyway, and then last bit, I'll talk about what you can do now in order to start making your changes such that you can adopt Anthos easier, and or just, as I'm going to call them, just best practices in general. So real brief history of Anthos. It was originally derived from a project called the Cloud Services Platform within Google, and probably most notably, Anthos and or Cloud Services Platform is not a thing. There's no line item, there's no SKU. Well, there is within Google. You can actually buy Anthos, but underneath it is a whole series of tools and practices that you have to adopt in order to support cloud native development. The entire platform is based on open source software, which is the purpose of doing this talk is to really highlight what that software is and why it became a part of the Anthos product. From its base, it was derived to be, or built originally to be a hybrid deployment solution. And so the smart folks at Google really started putting together their thought, put in their thinking caps and said, how do we make this such that it operates not only just in one cloud or in just one scenario, but how do we actually make this work across an entire hybrid deployment? And hybrid can be both on-prem and also other providers, which I will demonstrate. And lastly, it kind of consists of like 3 or maybe 4 layers, depending on how you look at it. And each of those would be basically an orchestration layer, config management, or policy management, service mesh, and then you could also say the hub of the connect. Really a hub and connect are a way, I'm not going to cover it in detail, but there's basically a way of saying I can package up applications and make them available for installation on any of my compute systems. So, kind of to start out here, the tools that Anthos are built on from open source, Google's been working on this for quite a few years now. I'll just start from the bottom layer and work up to the top. So the bottom layer is the orchestration. So this is how is your applications actually being physically run, or how is the compute actually being distributed? So Google, as everybody knows, came up with Kubernetes. They basically open sourced it 5 years ago when GA, well, not GA, I think it was GA 5 years ago now, it's a little bit roughly around there. Basically about a year and a half ago, they took that entire process of how they built their Kubernetes in their own clusters and said, let's make an on-premise version of it. And so they ended up using, I won't go into details, but they ended up using VMware and Big IP from F5 to be able to create an on-premise version. Now the nice thing is that it actually hooks up to the console up in Google Cloud as well, so you can basically effectively look like you have a single pane of glass for your entire Kubernetes instance. Additionally, they also helped work with Netflix and put out Spinnaker. So the Spinnaker was originally Netflix, and they kept it going for a long time. Google jumped in, saw the value of it, and started bringing it out. So that's another kind of an open source. On top of that, the next level up is kind of the networking or the traffic management, the service mesh. Google did put out Istio. That's one of their internal tools as well. Istio allows you to do quite a bit of, basically it's an abstraction over the entire networking and control plane. I will go into much more details, we're not going to talk about it now. And additionally, they also put out what's called a Multi-Cluster Ingress controller. I will briefly talk about how that became a thing, and then it's quickly not becoming a thing. The config management, open policy management, so when I first started talking about my other talk that I do on OPA, that's what that's really about. The configuration management is largely built off of that, or has a good portion of that. Infrastructure as code, they adopt a lot of effort is put into Terraform. Google went out and purchased a whole bunch of developers, put them to work building out the APIs on the Terraform. Anthos config management, which I will talk about. And then lastly, on the Connect and Hub, I do want to mention that Bellustrata is a company that Google bought quite a while ago, and it's really useful in order to do migration of applications and workloads into a Kubernetes environment or just into a cloud environment. So these are all kind of the tools that kind of sit behind Anthos in general, and so we will actually pick out and take 3 of those. So first one I want to talk about is config management. Config management within the ecosystem for Google is largely a concept called GitOps. So principle number 1, GitOps. So GitOps is a modern software paradigm where Git events trigger IT-based tasks like deployment, configuration management, and environment creation. So very, very simply put, if you don't know what GitOps is, quite possibly you're already doing it. So basically, GitOps is the concept where you have Git events. So I check in something, I push something, and I respond to it. So I can do some sort of an action, respond to those events constantly throughout the entire life cycle of software. And if we really break everything down into like how we do our software development, we realize that everything is really based off of our Git responses, our Git repositories. And so I make a change, I push it, that's the thing I want to have deployed. Well, let's make an event coming off of that. So GitOps was designed to be where changes are highly observable. So the Git systems themselves are incredibly easy to pick events off of those alone and be able to see everything. Git is a single source of truth. So we try to push for every single thing that you can do in your entire system to be in some sort of a code repository. It follows a good practice of continuous delivery. Git is a single place to operate for all environments as well. So again, no manual efforts. You want everything to be checked in, everything needs to be visible. Environment as a code is kind of a new concept, and this is the idea where we're using infrastructure as code to be able to design our systems, and we can put those all into code as well, such that I can then recreate my entire system through a series of actions that are based off the events in Google, or sorry, the code in GitHub or Git repository. Also, additionally, as we'll walk through here, you'll see that another principle is that they want to have declared state. So the idea that, we'll talk about what's called push and pull in a moment, but the idea here is that I want to be able to say, I want my ideal state when it's finally deployed and out to be what's in Git. I don't want to be additional efforts put into it, so no manual efforts. And then lastly, that kind of comes with a layered approach. Okay, so from development workflow, what it looks like is that I'm going to create some sort of a branch as a developer. I'm going to write some code. Maybe I'm going to deploy it to a local Minikube, or I'm going to write it to K3S, K3D, something like that, local build, whatever, commit it. Eventually I come to the point here where I say, okay, I'm ready to share this. So now I go to issue a pull request, and it says that now I want to share my code, somebody gets to view it. At the point where I'm actually creating that, in between there, I actually create an event. We can now respond to that event and say, what do we want to do? Do we want to deploy this to an environment? Do we want to code check it? There's a lot of things you can potentially might want to do. After that's completed, and somebody says, yeah, we code reviewed, this looks great, this is awesome, let's go ahead and go and push this into the environment, or as I push this into the code, we'll accept it into the master. We can then accept it, pull it in, and again, we have more events at that point in time. We can say, do we want to additionally now say this goes to another environment? Do we want to do something? So further up the chain, obviously there's a lot of events. I'm just kind of highlighting that there are quite a ways you could possibly break this up. At the same time, I want to mention that not only do you have this from a developer's perspective, but don't forget that everybody in the entire organization should be committing code. And so the team that does administration work can also be doing the same thing. I purposely put this slide up because I wanted to show already introduce that there's multiple options in which you go about in order to become, to implement a GitOps scenario. So Flux CD is made by Weaveworks, and it's another alternative to like the Anthos product. But the same concepts exist where I make some sort of a change and there's a synchronization pattern that happens that then makes my infrastructure consistent with what I want it to be. Oh no. Oh, shoot. 1 second. Technical difficulties. Oh, I hit pause. I didn't know this thing had a pause too. I've used it for like 4 years, and that's why it's all taped together. I've never hit pause before. All right, so then now this introduces an interesting thing. So if you immediately think, right now in your environments when you're working, you most commonly, if you don't stop to think about it, you're probably doing what's called a push model. And what this is that I make a change, my CI/CD picks it up and says I want to do something, and immediately goes and makes a deployment somewhere, or makes some decision to make a deployment, and then eventually progresses through. Meaning the CI/CD is the center point in which all the deployments happen. So as a corollary, the opposite is basically a pull model. And what we're doing from GitOps is we like to be able to say, can we put the changes we want into the repository and then have the changes be synced or pulled later after the environment in question queries or gets a notification that there is a chance to make a change. So a pull. And so I purposely put the arrow backwards. So after the accept and merge, it will wait, and the operator or the environment in question will say, hey, the change can be applied, pulls the changes in there, and then makes the application or makes the state consistent with what it wants. And so it's purposely an eventual consistency, which has pros and cons to it, but we'll talk about those in a moment. But it is a fan-out scale. So the nice thing about this is that you end up having 20, 30, 40 clusters that you have to work with, and you're making one change, and that gets applied everywhere. In a pull model, it becomes a very powerful tool. Likewise, the opposite there is the push change, and this is what you're probably most commonly associated with some sort of a change. I will tell you that now that both are going to be used in a good, proper working system. So in this scenario that I put out here, a pull request happens, Terraform plan pushes the updates to the environment, makes the changes for you. This is always happening usually within the CI/CD pipeline. It's very rarely that it would happen outside of that. Not to say it can't, but it's most commonly done that way. And so basically it would look something like this. This does scale at a linear process, meaning that you have your CI/CD pipeline that knows what all of its consumers will be or all of its endpoints, and they have to be listed and maintained, and it's not a subscriber process. It means it's very, very explicit. So it tends to be a little bit more imperative versus more of a declarative state. So in a push model, you always have a known state, and that's a pro. It means that you can automatically handle errors. Errors are a lot easier to work with because you're the one making the changes to the environment, or you wrote the code that will be able to handle the immediate. Terraform apply, and it says, hey, we got some errors. You can handle that error immediately. You don't have to get some sort of an update and go and dig in the log to figure out what happened. It's also very individualized, and so sometimes this can be very useful when you're looking at lower level environments that don't need to have, or maybe you're hitting the very first iteration. All right. Some of the cons, though, is it does scale linearly, and so this does take some effort to maintain and manage. If you have new environments that pop up, if you have a highly dynamic system where you're doing pull requests that are based off of, you have ephemeral environments that are based off of pull requests and feature branches and stuff like that, you can get into yourself a very big scenario where you're doing a lot of extra work that's not necessarily, not really needed. It produces centralized resource requirements for deployments, meaning that it puts a lot of effort on your CI/CD pipeline. And so if your CI/CD tool itself it's an anti-pattern, but if you have one tool that does CI for your entire enterprise, then you're going to put yourself a lot of effort in it because you're going to have a lot of builds. Now, on the other side, a pull is highly scalable. You can basically just hook up another system, and again, this doesn't have to be just environmental based. This GitOps process can be anything, but it's highly scalable because it's a pull. You basically reach out and you pull the information in, so it gives you a lot more broader reach with with less code. It is eventually consistent, which can also be very good too. I mean, that can be very useful where you don't need to wait and be synchronous on every single action that happens and wait. That ends up adding up a lot of time. If you just say, go out and do it, I don't care, come back and tell me if you had a problem at some point, that's when you care, that's a little bit different. You can end up with configuration drift. This is a problem with any automation. In the Anthos product that I'm going to talk about in a moment, there isn't a lot of drift on that, but not to say that it can't ever happen. If you write your own GitOps operators or GitOps process, just pay attention that that could be potential. So look at like synchronization times and making sure that things are in sync. And it does require quite a bit more automation and tooling. So I will show you one example, and I talked about the Flux CD. Those are two different examples there, but you will probably have to write a lot of this yourself. This is still a very, very kind of cutting edge technology. Debugging becomes quite a bit of a challenge too when you've got this idea of a distributed state. So I will take a moment to kind of back up here and put in, the first question that usually comes out to me when I talk about this is, well, this is great, I have one repository. Find out that real quickly, you're going to end up with a lot of repositories when you're doing GitOps, because you want to think about not only the number of repositories, or not only the actions that are happening within the Git, but who's causing them and what impact and what change do they have. So when we talk about infrastructure itself, and you're using infrastructure as code, I like to break it up into quite a few different repositories. At minimum, it's usually minimum at least 3, because I end up coming up with a global state or a global repository, which will generally handle things like networks. Like global level networks, like high level subnets. In the Google world, we're talking about XPN, and like how do you set up that first shared project, and then how do you set up the networks in there, and then set that up for the rest of your projects to be able to work with. That largely doesn't happen very frequently, and it very rarely changes. And so what you end up doing is you pack it all into there, and only a few people ever get to see that. Next level down, I usually have a segregation layer, which is usually a non-production production, because most companies have some sort of a policy that says their production can't be seen by other people, and so that gives you a very easy separation. After that, I usually come into some sort of a business unit rule, and that would be divisions or business units or something, some logical grouping of teams that fit under one common group. If they have their own repository, these are typically end up being either, I'm not going to say shared databases because I think that's a really bad practice in general, but like queues. Queues are a great way, or something like a GCS bucket or a GCR or something like that might be shared. Oftentimes this could be something where if you want to roll up but if you want to roll up logging and metrics at a business unit, you could do that, or you could put it at the production, non-production level, depending on predilection for your company. And then at the very end, each application will probably have some level of infrastructure as code that's dependent on that project. So my project needs a database, I write the infrastructure as code for my database, and I manage it myself, or my team manages it. Concept called pushing left, but I wanted to mention here that just with 3 teams, I'm already looking at 6 repos on one side, and that's going to mirror on the other side, so I'm looking at 12 repos. So don't be afraid that you have quite a few repos that are involved there. Set your system up originally so that way you can handle for the scale. Which brings up a good question, scale. So, actually I didn't even make that transition in my head and I just saw that. All right. All right, so there's basically two kind of primary methods in which GitOps scales. First one is adding more teams. And so as you need more functionality or new business units, maybe it's acquisition of new companies, you end up like scaling that way. So that's going to end up increasing the numbers of Git repositories that you're going to end up working with, which can also, again, like I said, like I mentioned earlier, could stress your system of your CI/CD. Secondary, the team dependencies, or sorry, the project dependencies are the other piece that can also help with it, or hurt the scale, or you have to at least account for. So on the teams, oftentimes you're going to end up with quite a few different repositories that need to exist based on the project and shared responsibilities of the team. It puts a lot of pressure on CI/CD. Secondary, the project dependencies, they tend to have some of the concerns we end up running into is that as you start gaining more and more responsibilities for that team or that infrastructure, those projects tend to get bigger and bigger, and the scale from that means that your build might have been 5 minutes to build a bucket in a project, and that was it. But now you're building bucket, Kubernetes, maybe it's a spanner, and all these other. Next thing you know, your build's now 2 to 3 hours long. And so the concern that also has with that is its broad scope. So if you keep packing more and more stuff into a smaller project, you don't have them spread out. The concern of a big bang or a rapid change can be a big thing to worry about. So pay attention to those early. Enterprises typically need to also think about how do you do authentication with your Git repository. Git itself is not, like the tools that we use, are not really built for authentication. They were never really built for the idea of like, well, people can see this, but not that, but kind of this, but not really. That's only a newer concept. GitLab's done a lot of work with that, and GitHub is picking back up again and bringing those in. But those are still concerns that we have out there about authentication. So this may not always be an immediate fix for everybody. So to kind of back this up with the repositories, I kind of want to do real briefly over the two different major styles of branching techniques that exist. So we have what's called Github Flow. The whole concept of a Github Flow branching is that everything's derived off of master, meaning that you're only making commits only to trunk or only to master. Every time you want to make a change, you fork a branch, and it's called a feature branch. You make your changes, and you push those back down into production, or push those back down into the master branch. Now, the cool thing about that is every single thing that's on master should be produced and pushed out into production, or capable. Secondarily, the alternative oftentimes becomes GitHub Flow, which is where you end up having some sort of a feature branch, you have an environment branch that you're then making changes off of. This allows you to encapsulate functionality for a week or two, depending on what your company needs, and not release things early if you don't have the that's the right word. If you don't have the maturity in order to handle feature branch or feature flags. All right, so I'll talk about the actual Google one here. So what they call it is their GitOps operation. They call it the Anthos Configuration Manager or Config Manager. When you go to use this, you do have to have the Anthos product installed in here. So if you don't have that, you have to use an alternative like Flux or Ambassador, but I'm going to talk to the one that actually Google has. So basically what you do is you have a Kubernetes operator. That's the very first thing you do, you install this operator. The job of the operator is to basically listen to the API for changes coming in and say, can I do something about this? From there, you install quite a few about 4 or 5 CRDs or custom resource definitions that respond to the API and say we can do something with it. Then you end up configuring the cluster configuration, and this is where for each cluster that you work with in Kubernetes, you end up installing what does each one look like, and how does it find its configuration to pull down and make consistent. Then you make changes to your configuration, change it, push it into Git just like you normally would, and you observe your changes. So I do want to mention the open source alternatives. Flux is probably the most mature one out there. Ambassador is another product that's a CNCF. Well, it's not really a product, it's more of a logical concept that's out there, the CNCF, but if you ever take one of the Kubernetes exams, you'll see Ambassador multiple times. So it's kind of weirdly tied together. And the last one I have Spinnaker on there. Well, Spinnaker isn't an operator-based GitOps. It is some way that you can do a push-based configuration based completely off of Git. So I put together this to kind of show the blend of how I would see a recommended approach to using GitOps. I like to say that we have both a push model and a pull model. So each of my different 4 projects on the left-hand side there, they have their normal CI/CD. There's nothing different there. And then you get to the point where you say, I have a version artifact. I want to make a change to this. So either version artifact could be infrastructure-based or it could be code-based, something like that. Doesn't really matter what it is. It's a get event that says I have a material change at this point in time that needs to go out. So what you can do is you can have your CI/CD pipeline actually do something at that point in time and say, I want to push this to a dev environment. A dev environment is typically very ephemeral or very high change. It's in flux all the time, so it doesn't really matter that there's not stability to it. And the developer just wants to get it out to get it working with other services that exist in the ecosystem. So a push model is very good for that. From that model on, it's great if your system can say, all right, I pushed this. What if I now take that change that I made and push that into another Git repository that holds the state of what the environment needs to look like? Because that's the point of GitOps, is to really say, I have an observed state and I'm going to hold on to that so I can roll forward or roll backwards if I need to, but I've encapsulated that functionality. So at that point there, if you could call it a success or whatever you want to do, depending on how you want to configure your CI, your pipeline, deem it a success, well now it commits it to another branch, or maybe it commits it to another repository, or makes some other change. Now I push it into a scenario where like maybe it's QA or stage or something like that, where I don't want to have push. I want it to be much more controlled. And maybe I want to distribute it over multiple different clusters rather than just one. Get that testing period early before it gets out of production. Well, that allows me then to go ahead and push or put that into the repository and then use a pull method into the repository or into the environment that I want to do and make the changes there, make it consistent. And then I would iterate that one more time. I know if you're a startup, you only have two environments. You have dev and production. But if you're an enterprise, you probably have 2, 3, 4, or 5. And as we actually think about software better, those environments should start becoming logical, and we no longer actually have just 1, 2, 3, or 4 environments. We should have hundreds of environments and only alive for the period of time we need them because we have software to do that, because they have different purposes. And so for the Anthos configuration explicitly, the very first thing you want to do is we're going to end up running the operator. I will open this. I'm not going to go into it, but I'll show that I have it. How do I minimize this? I'll try that. So on here, like I said, there's a series of custom resource definitions that end up getting created that end up basically managing what does the entire ecosystem look, or what does the infrastructure look like in order to hold the configuration we want to work with. So the important part is I actually end up creating 2 clusters. I have a GKE cluster and I have a DigitalOcean cluster. Because DigitalOcean now has Kubernetes clusters that you can start and stop, which is pretty cool. And it's a lot less effort than Azure and EKS, so I have limited time. So what this does is, this is the size of it. There are other configurations you can add in here to make it more or less on different things, but at its core, I basically have a Git repository that I'm pulling from, and I give it a name, so GCP for GCP and DigitalOcean for DigitalOcean. And basically on each of the clusters, I run this. So the only manual steps that I have to do is creating the cluster and then running those 2, the operator first, and then the selectively which configure I want to do. That's it. That's the only thing I have to do. The important part is, let me minimize that. The important part here is the configuration repo. So this points to this repository here. And what I'll do is I'll briefly walk through a couple of these just to kind of give some understanding of some of the flexibility and power that sits behind Anthos that allows you to make this consistent. The beautiful part about this is you can run this cluster locally, you can run it on multiple different providers. It doesn't really matter because it's going to reach out, it's going to use SSH or some other security mechanism to pull down the configuration and make the changes within the cluster. What you do with it from there is a different story. So, before I get into this, so we basically have things that are cluster-wide. So this allows me to make any changes that are cluster-wide. They typically end up being things like service accounts and cluster role binding and roles and stuff like that. In the cluster registry, this is how I can now, the cool fact is that I can now create something in my Git repository that say only in my DigitalOcean do I want this to be applied, not everywhere. And so I can make selectors. And these selectors allow me to do, let's look at this guy. It means I can basically look at anything that has a cluster environment GCP label on it, meaning this is at the node level, allows me to say I'm only applying my changes there. So I have a little bit of level of flexibility and control as to where these things go out before they get changed on the clusters. So those are pretty straightforward. you actually get to define the different clusters themselves as well. So these will automatically be applied. They're only going, you'll see the anchor here is this name is GCP. It's going to be tied off of the, when I made that configuration change, that's what that tie happens between those. From that point on, I'm never running, I'm never even touching the cluster for any type of change in the configuration at that point on. It's now off limits. So that's how that tie happens. So, comes into the fun part here. Almost everything is usually done with namespaces. And so if you don't work with Kubernetes enough, namespaces are probably the best way to encapsulate functionality. Allows you to be able to manage resources a lot easier. Things like ephemeral systems are awesome to run in namespaces because when you're done, you just kill the namespace. You don't have to kill everything else individually. Makes it very easy. Also, lock it down so that way you don't accidentally delete your production namespace. All right, so what, oh, actually, I checked out the wrong one. 1 second, we're gonna build one of these. So, with that being said, all right, 1 second. So if you've never used Kubernetes before, this is a tool you absolutely have to install if you're doing anything with multiple different either namespaces or multiple different clusters. kubectx is a little tool written by some folks here actually in Seattle. And what it does, it just manages all the configuration files for you so I can hop back and forth between them. So you'll see I have 2 clusters. I have one, I have Anthos principles, GCP, and I have a DigitalOcean. And what I want to show is that I'm going to make a change. I'm going to show both of them to start with, but namespaces. Then we're going to make a change, and we're going to see that change reflected between 2 of them with me never logging in or never doing an apply on those. So that's the first part. So first what I'll do is I'll demonstrate both the 2 with the namespaces, and we'll make a change, and we'll see those things happen. We'll see how easy it is. So I'm on the Anthos, or the GKE one. We'll see here, just I want to point out there will be at some point some change. We'll put in a development environment or a namespace. Changing to my DigitalOcean. Run the exact same command. It better be the same. Good, they're the same. All right, so now what I'll do here, we'll go back here, and I'm going to let's add a development namespace. Oops, maybe I should spell that right. And I'm going to create a file inside of it. And I'm going to be sneaky, since I don't memorize these things. I'll describe why I have this little issue too. All right, so now if we're doing this as a, let's see which folder. Not the right one. So if we're doing this as an actual like change in a real like a real environment, we would actually make let's see. So it would actually go through a full pull request and everything. I'm not going to do that now because it's not useful. But I'll go ahead and make a push here to my Git repository. Now, while I'm doing this, I'm going to describe another tool that Google created. It's called Nomos. It's a tool that allows you to take a look at the different configurations themselves and actually look at errors and bugs and things like that. It actually is very, very helpful. In this case here, you'll see that it says that my sentences are synced. It gives me a number. I probably should, I don't know if it's, yep. And now you see there's it's syncing and pending. So now when hopefully it's done. So now if I do back to my namespaces here, now you'll see I have a development namespace that exists here. And all I did is create a change in my Git. So, and we'll do that for the GCP one as well. So I think that's super powerful. That really shows that I can have everything, my desired state is actually in Git, and I'm using these operators here to make a change and synchronize those. I'm not going to go into the painful extra piece that I was going to put together, but I can add an annotation as well that allows me to, actually, if I can, let me do, I'll show it, but not do it. Double bend. I already had this completed at one point. So I do little things like sometimes I'll add like labels there to be able to say that I want to indicate that it's something I created. It's just for me, for helpful. And then the next section we'll talk about Istio. This is a great way to say, hey, I want to guarantee that I can use the Istio label, which will automatically inject sidecars into my containers. I just put this into my development information here. I never have to go in and run a kubectl command for that. Here's one example about how you can make, so I have a GCP only. I can use this annotation here, this selector annotation. You'll see that it has the name of the cluster that I want to do, and that was back from the configuration, cluster configuration section. So now this change would only exist only in the GCP cluster, whereas the DigitalOcean one would only exist there. I don't need to demonstrate that now, but I kind of want to point out that that's how you can handle that. Or maybe I didn't. No, I didn't. Okay, so service mesh, I'll come back to that, what that means in a moment here. Within Anthos, they call them traffic director and managed Istio. So the concept is called a service mesh. There are quite a few different ones out there now. Istio is probably the most popular, but there's Linkerd. Every single API gateway out there has their own version of a service mesh now, and it's just going to continue to keep getting bigger. I don't know how they all work together. They may not. Or actually, it just might end up being a whole bunch of soup at some point. So there's a lot of best practices that we don't yet have because we haven't hit all the major problems. All right, so basically a service mesh is a dedicated infrastructure layer that controls service-to-service communication over a network. It adds the entire abstraction of how services talk to each other, which gives you a lot of really cool opportunities to inject functionality at different points in time and kind of hijack things. So Istio, like I said, was largely created both by Google. It's Google, IBM, and Lyft, like the car driving company. All random things. And they ended up coming out with something called Envoy. Envoy is the application, or is the server that basically sits in the background on all of the different services that you end up creating and provides the proxies. It's built to be very, very fast. Cool thing about service meshes is it allows you to start taking the functionality, the fat libraries as they typically call them, and pulling them out of the applications and pushing them into a different layer. And this is incredibly beneficial. So if everybody did Spring Boot and everybody in the entire world, we wouldn't have a problem because Hystrix worked well enough from a circuit breaker perspective and some of the other service discovery things. Those worked well enough, but it was all built into every application. Well, sure enough, not the entire world uses it. There's all sorts of other languages, and it's becoming more prevalent. I don't think that there is a circuit breaker application for, I don't know, COBOL or something like that. So if an application runs like that, it needs to have some level of control over the service, the networking control. It doesn't exist. So we pull it up, make our applications lighter weight because they don't need to have that. Plus, their operations no longer needs to think about, okay, that's a Java app, hey, that's a C#, hey, that's a whatever. They just think, hey, it's an app running, and that has been abstracted out. At its base, Istio is made up of a couple different applications. We have what's called Mixer. Mixer is the telemetry and policy control. So policy meaning that what applications or what networks can talk to which networks or what's the control path there. You have what's called Citadel. Citadel is the authentication and identification of applications between them. So auth-in, auth-z is in the Mixer. We have Pilot, which is the traffic management. So they do separate the traffic out so that from the authentication, so that way the patterns. What you'll see in a moment here is that we end up pushing all of those configurations down to the different little proxies as well, so that we have a very fast operating the same machine because everything's local. And then you have Galley, which is the configuration management largely for Istio. It's something that you very rarely will touch or even see. The last one is the Envoy proxies themselves. See the proxies are sitting right next to the applications. And the purpose of that is because if you put them in Kubernetes, If you're not familiar, Kubernetes, you have what's called a pod. A pod can contain one or more containers. If you have 2 containers or more containers, they all share the exact same network space and the same disk space. And so if I put a proxy in with this and have it run the network, and I have my other container just talk to localhost, I've now been able to inject functionality into my pod or into my application running kind of seamlessly. It's really, really kind of cool. So the principles of Istio, observability, so everything can be seen. And so there's a lot of metrics that are being pumped out of the system the entire time. Scale performance, as I mentioned, the proxies, pushing the configuration of the proxies and having those available, at least portions of that, are incredibly important for performance. That was a core start. Dedicated interface between networking and traffic routing. So it's not just networking, it's not just traffic routing, it's that interface that works between them such that they can communicate and work together. Security is a core component. High degree of flexibility. So the cool thing is, like, you usually hear Istios talking about working on Kubernetes. Truthfully, it can actually run on anything. So as long as that proxy exists, you can run it on a virtual machine, you can run it anywhere. It doesn't really matter as long as that proxy exists within and is visible to the control plane. And then the independent deploy method is kind of the same sort of point there, where it doesn't have to use Envoy as the proxy. You can actually swap out Envoy for something different. If you have HA proxy or Nginx or something else, if you really want to use something different, you could. There's just a matter of configuration, and they have an adapter that will work for basically any serving capability. So the primitives that exist within Kubernetes, there's about 4 major ones that you're going to work with from basically a general developer's perspective. First one's what's called a gateway. This is very similar to an ingress controller. In fact, it actually replaces the ingress controller. Ultimately, it's what you're trying to do. It provides ingress and egress for your service mesh. It's important to note there that in Kubernetes Basic, they don't have an egress. There's only an ingress. In Istio, there's an egress as well. So you can choose what traffic gets to talk outside of your cluster, and you can actually manage that as well. It means everything from policies or rate limiting or whatever, rerouting, rewrites, adding headers, all sorts of cool stuff you could potentially do to it. It basically describes a load balancer at the edge of the Istio network. The gateway itself actually does use a load balancer in the background, and actually creates a series of pods and puts that right at the edge of the Kubernetes infrastructure. It does not do any traffic routing either. The gateway is literally there just to say it's an ingress and egress, and it sets up a lot of hosting information, but nothing else. So that's when I was talking about the different products or components that exist of Istio. Routing is itself its own little entity itself, and I'll show you why in a moment when we get into destination routes. All right, so next level down from there, a gateway will talk to virtual services. Virtual services are just as they sound, they're virtual services. They exist as basically a grouping of, it's a way to like do your first level of traffic routing. And so what you're looking for here is you're starting to look for things like, I want to match on things like headers and hosts and cookies and URL paths. There's a couple different 5 or 6 different types of routings that you can potentially look at for matching, which would then say, now where I want to head this to. So I just put up a couple examples there. I have things like, I have a host, you could have multiple different hosts that you want to accept this virtual service from. So it could be development or production. You can put them all into one, doesn't really matter, but then you can do things like, okay, now I want to match like these headers. So the cool use here on this header, it could be for sticky sessions, which good or bad that they exist, but you might want to use it for that. Also, user testing is actually really big for this. If you end up setting a cookie or setting a header with a customer, or you have something upstream where it sets a header ahead of time coming in, you can automatically route right here into, in like a very coarse way, say all traffic that goes from that is going to get this whole completely different set of service versions than others. And then at the bottom there, you'll see that I have it routing. In this case here, it's just routing to a port, but I probably, in retrospect, before I get this again, I'm going to change that to destination routes, which are up next. So destination routes are the next piece. These are probably the cooler part of it. When you hear about Kubernetes, or when you hear about Istio, you always hear about canary builds, and you hear about like traffic splitting and things like that. This is where a lot of this power comes from. So what I can do here is with a destination route, is I can set up what are called subsets, and Sadly enough, it's not listed here, but right here at the bottom where it says route destination port, I can actually tell what subset I wanted to go to. I didn't, unfortunately. Note to self. All right, but this is where I define what those subsets look like. And you'll notice that there's a subset name, then you'll see labels. Those labels are exactly what you use in Kubernetes. So when you're making a deployment and you have a series of labels for your application, and then in your service as well, service is looking for all the pods that exist from those labels. Those are the exact same labels. And so what I can do is then if I have two different deployments, one is version 1, one's version 2, I can then make two different subsets in here and then say, I'm always going, then I can use those for traffic routing from my virtual host to say, I want to weight it at 50% to one or 20% to one and 80% to the other. Whatever I want to do, you can do some pretty crazy stuff there. So that's where the sets are done. So now I've got a split between my subsets that I want to go to, my traffic routing, and my host as well. All right, and then the last one here is because we end up working with services that are not always within the cluster, there's a concept called a service entry. These are really close to endpoints that exist within Kubernetes already, but the concept is a little bit further. This is now introduced into the cluster, meaning that I can now manage that traffic. These are really good for things like databases or endpoints that exist outside of the cluster. Like, if you're going to another service, like a weather service or something, I don't know. Whatever might be useful, right? Anything outside of your cluster. And it allows you to then manage this within the cluster itself. Cool thing that I thought about, or didn't think about, but I read an article about a year ago that when they're introducing this and they're talking through it, if you have control points over every single thing you touch in your cluster and outside of your cluster, you can then dynamically route your traffic anywhere. So database A goes down. If you have some sort of, if you're doing like master-slave scenario with your database and all reads go to like one of 4 different databases and one of those goes down, Istio can automatically reroute that for you. You don't even have to, don't rely on the vendor to have to make those opportunities or changes for you. You can do that yourself. So it's really kind of cool to think about that. Also, think about it geographically. If you have a geographically consistent database, which we'll call it consistent, whatever, but say you have something like that and you want to have, service A reads, and you want it always in Europe, you can use these entry points allow you to have that point make it available such that when you have a multi-cluster scenario, you can't reach out to the closest one to you using Anycast. So some cool stuff. So I kind of drew up a little diagram to kind of show how these kind of compare both from an Istio and from a Kubernetes configuration. So the left-hand side is what you call your typical Kubernetes configuration: ingress controller, service, deployments, pods, endpoints, and then touching to an external database. On the right-hand side are kind of the corollaries of what Istio provides for you. So you have an Istio gateway, which has a virtual service, which then can point to some numbers of subsets. Those subsets then directly point back to the actual pods themselves that were from the deployment. And so you're not creating a completely separate flow, you're kind of augmenting or layering on top of the existing infrastructure for Kubernetes, which is kind of cool. So that way you only have to additionally train, not just create a whole new separate flow. So. All right, so Google also created what was called the Multi-Cluster Ingress, or MCI, Cube MCI. They are deprecating this now. The last touch of this was about a year and a half ago, so they really haven't put a lot of effort into it. Instead, they're not necessarily deprecating it, they're moving it into the kubectl command itself. And what this does is this allows you to say, I've got multiple different clusters, how do I want to geographically load balance across those, such that my compute will be done closest to the user. So there's obviously a lot of questions that can come up with that and whatnot. There's a lot of caveats that exist currently. At some point it will become bigger. It will become part of the tool, which then will be a little more commonly used. Basically, the couple of caveats that you have is that you have to have the exact same configuration, namespace, and applications or deployments in each of the different services. They have to be node pools, which, if you're deploying for production anyway, you're going to use node pools, so not a big loss. But what it does, it uses Anycast, which is Google's kind of hack on BGP to allow you to geographically route traffic at a level 7, very, very high level, to the most appropriate cluster for the destination. It's pretty crafty. Let's see. Yeah, so that's basically about it. I do want to mention that there's only, that's one of a couple options. The option that I want to show here is in Istio, you have the option of creating multiple clusters, or have multiple cluster configurations. First one is what's called a replicated. There's basically three options. First option you have is a replicated control plane, meaning that every single cluster has a control plane, and you're probably managing, maybe it's GitOps based, and you make one change and it does it to all of them. That's a good way to go about it. But either way, you have to manage all of those different Istio configurations, and you want to try to keep them consistent so you don't get drift, so things work. So that's the first option. That's the easiest option. Because you have no connectivity between the clusters. They don't know about each other, they just operate exactly the same. So kind of think like single tenant like a multi-tenant. So the second one is what's called a control plane, sharing a control plane with a single network. This is a little bit more complicated. If you have the capability of sharing networks, meaning interconnect or VPNs that basically hook your networks together, it's a little bit of extra work because you have to worry about IP overlaps and some of those types of things. But that's probably the second easiest to work on, and you can kind of connect everything together. Istio will have one control plane. I mean, you have a redundant, but you have one major control plane, and everything will kind of hook back up to that. So all of the all the configuration for Pilot will exist in one place and push down to all the different proxies. Now the last one is the shared control plane multi-network. This one here, that's kind of what the diagram there looks like. It's the idea that you're going to have still a single plane, but you're going to have multiple different networks, and so you're going to end up sharing cube configuration to be able to have them operate between each other of the different configurations. This one's the easiest to do if you don't have access or you have disparate systems that don't talk to each other normally, to be able to run configuration or Kubernetes clusters together all in one. So cool thing is any one of these, if you have a large enough infrastructure, you'll probably be doing 2 or 3 different versions. You might be doing all of them. So there's not one size fits all. It kind of depends on what your needs are. If you're using things like a lot of edge-based configuration, like edge tools, so if you're working manufacturing and you have like a plant floor and it's going to go in and out, you don't have that single network. The last one then down there, the multi-network, is probably the one you're working with, or the replicated control planes, depending on how much compute you want to spend, because you have to maintain all of the clusters. I will tell you, the Istio does take up a little bit of compute. All right, so then the first thing I want to mention is that we mentioned the virtual service. So my virtual service here is going to accept all hosts, and I'm using my gateway, so there's the binding of it. Now here's where I come in and say, I want to route all traffic. I don't have any matchers, so it's all traffic's coming in. I want it to go to my simple app service. This, if you're not familiar with this, this is the URI for Kubernetes. Basically, to get this down to, this first piece is my service. Second one is the namespace, and the rest is kind of, it's a service, it's in a cluster, and it's local. So it's the DNS for Kubernetes local. I'm going to have it point to a subset. So right now at this point here, we don't know what that subset necessarily is, and I want 100% of that to go there. This is just hanging in there. All right. So I go into my destination rule, and my destination rule here has TLS is disabled, because that was the last thing I did to get this to actually work. I have this set up to be on a random. This load balancer can have quite a bit of extra logic to it. You can set this up to work with Prometheus and other types of kind of metrics-based systems, or I think maybe it's only Prometheus now, but allows you to do some sort of predictive routing if you need to. There's also like least commonly used and a couple other algorithms. Anyway, so my subset here, my V1, is I'm looking for applications that have the label V1. This is not something I would use in production, because if you accidentally threw V1 in there, who knows what you're going to get in production. So it would probably have a series of a couple different labels, just caveat. Anyway, so that's kind of how that looks. And so by deployment, nothing special here, it's just Kubernetes. Except for my editor somehow makes me want to always put in the resource limits, which is a good practice, but not for a demo. I have an Echo server, is all I'm running. It's just the Echo server. It's on port 8080, and nothing special here, right? But it's important to note here, here's my label for V1. So when I go down here, so hopefully nothing changes here. in the GCP. So nothing's changed, but basically I just run the gateway, I run the deployment, everything. So now if I do a get all, normally I have a headset on, so I'm not like constantly changing this. So you'll see up here, I only defined one container, but you'll see there's two. And so the reason why that is on my namespace, I have Istio has the auto inject flag that I put on the label, which means that every single, it's a part of the acceptance controller that was built by Istio that says if that label exists on the namespace, every single pod that comes in there is automatically going to get the proxy. And so that's why I have 2 of 2. So I actually wrote 2 of them. I have my first deployment here, which is the one we fictitiously would have just done. I have a deployment, I still have a service. Everything's normal, right? So what I can show here is, maybe, we'll jump out of the demo here. I can show you that I actually created a load balancer for it, and this is what the app looks like. Well, great. There, so that's what it's supposed to look like. And there's the, if you guys watched Slack today, I actually put out a, hey, does anybody have something cool? Because it'd be awesome if I had a little app that said, I pass in an environment variable in it and tell me, like, you're on version 1, you're on version 2. Someday I will write that. I've been asking for it for about a year and a half, and I've never done it. I just need to do it. Anyway, so this is just an echo. All it's doing is saying header information back out. So that's the first one. Now, notice that this, I want to point out, this is a service for Kubernetes. This is not Istio. So when I go here, this is my Istio ingress, or my Istio gateway. If I keep refreshing here, I'm going to get the same thing, because I've set this weight to be 100%. So now what I'm going to do is I'm going to come in, and we're going to change this weight on the, and we're going to change this to 50-50, or let's do 100, just to kind of show that, oops, 110, I don't know what would happen if it, I actually have no idea what would happen. I've never tried it. I've always been a good guy, and never been like, hey, what's 120 look like? It displays, it refreshes. It's like, we're getting 120%. All right, 1 second. Okay, so now we see that the app config changed. So we'll go back to here, and then hopefully this will switch. Yay, here's my other one. It's the same version, but it's a completely different container. So that's the best way I can show that there's a massive change between them. So this is the hello world. Now, obviously, if you're thinking about doing this from a canary build or something like that, you would want to have this fully automated. You probably wouldn't want to actually have a whole bunch of check-ins and get stuff like that. That's where the power comes in. I didn't have a chance to get that done yet. So, all right. So I'll go ahead and apply this here with a 50-50 change. And statistically, it's 50-50, so you can see it just bounces back between them there. So this is going to be incredibly powerful for everything from A/B testing to ABCD. Like again, the subsets can be set up by any means that you want to have them set up to be. So. All right. So that was the only thing I wanted to show for Istio at the point. There's a lot of stuff into it, and you could do an entire, multiple talks on just Istio alone. My goal isn't to teach that. My goal is to show what can be done with, or what the principles again are behind Anthos. So same thing with the Azure as well. Okay, so the last principle I'm going to talk about is serverless, and so you'll hear a lot of cloud runs. You hear cloud runs very, very common. It's one of the things that they've been pushing out. It's serverless at the container level, not serverless at the function level. So opinions aside, I think it's a good split to be able to have the application itself, the container itself be the serverless component of it, versus re-implementing the Java serverless spec into JavaScript functions in Amazon. All right, so Cloud Run is basically Knative. So Knative, again, is another open source application or open source framework that exists that Google has put together. Worked with Pivotal and I think IBM as well. IBM's been on a couple of these. IBM's trying to get back in the game, so they'll do whatever they can. So. All right, so Cloud Native execution model in which the provider runs the server and the service basically dynamically manages and allocates the machine resources. So serverless is not Lambda. Serverless is the idea that the developer says, hey, I just want to run this, I don't really care, just get it going. Now, it's our job as good engineers to be able to take a look at that and make sure that we make it so it's secure, we make it so that way it's consistent, and we make sure that things like networks and identity management, all of a sudden, are kind of handled. So at its core, Knative is designed to be automatically scaling plus and minus, up and down, and also scale to 0. It doesn't help you from a cost perspective, but it helps you from both a running runtime and usage perspective. Well, kind of cost, but marginally, not like going to actual 0. All right. It's meant for rapid deployment of serverless containers. So again, developer has something, they just want to get it out, just get it out. They don't want to focus on all the other stuff. Producers, so I'm going to mention there's kind of two components. One's called eventing and one's called serving. I'll talk about that in a moment. The reason why some of the principles here sound a little odd. They have an event system that's built into this. And so producers are able to create what they are going to produce before there's consumers. Consumers can say, I want to register for something before it even becomes an event, so that way they're loosely coupled from each other. So that's an important key principle. Routing and networking is done via Istio, and that's how you do things like every single time there's a change, there's a brand new version, and it's how you can actually rotate and basically pass traffic from one to another, one version to another very easily. The principle is loosely coupled services, as we all should be doing anyway. And then point-in-time snapshots for both the code and configuration of your application. And that's kind of an important piece to be able to say it can, again, roll forward, roll backwards, give you confidence that the services that you're putting together are able to be used. All right, so from a very high level, there's two core components. I'm going to actually talk about three, but one of them, I'll tell you why I'm not talking about it much. First is serving. So in serving, it looks very, very similar to a Kubernetes manifest. That was on purpose. It can basically be run from a Kubernetes command line. The idea here is that they're largely abstracting away all of the components that you would normally see within Kubernetes away into just one file. So in this case here, I'm writing a service. If you notice, I'm not writing like with Kubernetes. This would be two files that you'd be putting together. Both the deployment and the service. In this case, we're just doing just one. So you'll see a lot of commonality between them. It's meant to be very request-driven. So these aren't like background jobs that get created or cron jobs and all the other extra things. These are meant to be just request-based. Let's see. Nice thing too is that we're encapsulating configuration along with this. So you'll see things like environment variables and everything that goes into a service exists within one file to make it very easy. It allows you to create a point in time. So a service will basically create in the background, it'll create what's called a configuration, which is basically your container, like what are all the options for your container, environments, and all those kind of things that go together. It'll create a route. So how does this come from the Knative system? You can set it up so you can have domains and hosts and a whole bunch of other things. Again, all this is abstracted away from the developers because they don't care. All they care is that the service comes out in some predictable method that they can then reuse. And so this creates a route for it. At the same time, that route also means like version 1, version 2, version 3, version 4, whatever that might be, such that those two things put together end up being a revision. And so a revision allows the Knative to be able to come in and say, run this version, run that version. You can change them very, very quickly. If it's a stateless application, very, very quickly. If it's stateful, don't run it in Knative. All right. Okay, so eventing is the next concept. So eventing is a way of being able to say, I have both a service, a consumer, and I have a producer of events. These are built in because a lot of what we do from software is event-driven, so let's might as well build this into the system. There are a lot of different sources type. I just put the GCP pubs up here because I'm speaking on behalf of Google today. But this can be everything from Kafka, it could be Kinesis. There's a ton of different ways that you can potentially consume these. Also, you can make your own. You can have container-based, where my container does nothing more than just emit messages, and so it doesn't even have to be anything. Nice thing is that there's generally a format, a protocol that you would want to use, but you don't have to. You can make it for anything you want. But there's an industry standard, or they've created their own standard for what messages should look like. And basically, think about it as just being like a wrapped message, like in an envelope. Let's see. At the top there, you'll see that I have some information about how you would end up getting those in. You'll see secrets. Those secrets would actually be Kubernetes based again. So largely it's built on top of Kubernetes. It's not meant to be a replacement for it, and it's not running alongside, it's running on top. At the very bottom, you'll see what could be essentially, in this case here, it's just a message printer, so every time it gets a message, it just emits it. Nothing fancy, but this could be used in a lot of different ways. So again, this is kind of how Cloud Run runs. So in this case here, just a real simple diagram of what the event source kind of looks like. You're putting out different types of types. I don't know what the word flow means there. That was not my diagram, but your event consumers there are the ones who, my guess is it just emits it out to empty space, because that's the hookup for, you don't have to have an event, or don't have to have a consumer. All right, so the last one here within the Knative, it's still in here, but it's being deprecated. The last one was build, and this is actually, I felt, was kind of a cool component to start with, but after a little while, I realized that it wasn't. So the build would be the idea of, like, I made a change in my Git repository and just push it out to a dev environment. I don't even care, I don't want to do anything. And when I say it exactly like that, we realize that our CI is doing that anyway, so it doesn't need to be in into the platform itself. So they're pulling that out. It's going to be removed here within 3 cycles, and instead they're recommending using Tecton. If you haven't heard what Tecton is a method of putting CI/CD pipelines into Kubernetes. I really like the idea of having my CI/CD pipeline separated from my cluster. I don't want the resources consumed within my cluster to be part of that. Also, if you ever look at the YAML, like, we don't like doing the YAML anyway. You really won't want to do YAML then. So it's kind of a pain in the ass. There's a lot of different components. There's what are called tasks. Tasks are your individual build steps that you have. You have a task run, which means I'm actually going to do an implementation of that. Then you have a pipeline run, and pipeline resources. There's a lot of extra junk that goes into this in order to make it performant. I personally don't think it's there yet, but here's kind of how a CI/CD pipeline would look inside of Tecton. You have a pipeline run which uses the resources. Those resources might be things like a bucket or artifact repository or cache or name it, anything. It's just a resource used by it. Pipeline, and the pipeline runs a whole series of tasks. So the way that we want to work from a Knative perspective as a developer, in order to make this, again, as serverless as possible, you do all your normal stuff, everything up to the merge request. At that point in time, this is where I'm recommending not using Tecton. I would end up using my own CI/CD pipeline, whether it be Cloud Build or GitLab or GitHub. Doesn't really matter as long as you're in a CI. Then end up running like basically your Docker build, Docker push, so your image goes up, push it out there, and then you have a queue apply with your service on it. The only thing that's required to run, well, besides the installation of the system, but the application needs to have a service.yaml file, and that service.yaml file then defines what the service looks like. So that's the only additional piece that you have in your repository versus anything else. Now that we've seen the 3 kind of major primary elements behind Anthos, and we know that it's not a line item, it's not a SKU, it's not a single thing, it's a series of practices and principles and tools that you use in order to make your application more resilient, we can then talk about how do we go now. So this list, surprisingly, I pulled the vast majority of this from every talk I've been doing for the last 10 years, so nothing's really changed. You want to have a consistent, predictable CI/CD pipeline. That's going to be the same no matter what. That removes your risk. You want to have 12-factor apps. Push for that as much as possible. Isolate your change, isolate your state, and keep that out of your applications, or put them into a very explicit application to handle it separately. You want to externalize your failures. So rather than having circuit breakers inside of your applications, use Istio, use tools like that where you can say, I want to respond when I identify that there is a problem, not also identify there's a problem and respond as well. Move that outside. Allow the circuit breaker to trip somewhere else. Have it send you, 503 or 502 or 401, or I don't really care when it comes back, as to what the status needs to be for that, what represents the failure. Have your application only handle it. Don't also have to identify all that as well. And that goes with almost everything else. Right now, think about every single stage in your entire build, what events can happen when you get, label them down and start thinking, what can I do with that? Can I, the fact that I just created a new branch, does this mean something? Like, whatever webhook could possibly exist within your system, can you respond to them, and do you need to? Let's see, increase your trust in your development. Again, adding a lot of layers. So I mentioned in my beginning, we were talking about the infrastructure as code. Write layers of infrastructure as code. Write layers of applications as well. Things that can you want to isolate critical elements and put them into repositories that will never even be seen by the common person who might mess things up. You don't want a junior developer coming in and dropping your global network or giving all access to everything. I'm not going to read the rest of these, but I'll say the middle one there is probably my favorite. Automate everything. Everything needs to be automated. So spend time. If it's painful, do it more often because you will find a way to automate and get rid of it. And then I will mention, have as many repositories as needed. Don't be fearful that you have 500 repositories. It doesn't matter as long as you have a system and a method for governing what those are. The only reason you tend to put them all into one is because you're afraid that you're going to miss something. So have a system. So what's missing from my talk that Anthos has that I did not talk about today? So traffic director is a concept that Google has where you can look at a graph that shows you where your traffic's going everywhere. There is a Kylo, I don't know, K-A-I-L, I don't know, Kylo, whatever. It's a graph system that works with Istio that you can then look at your traffic from there. It only works cluster to cluster for the most part, or if you have the multi-cluster, you can kind of see across that, but it's not nearly as cool as the one from Google, where they also show you things like all the SLOs that you can put in there as well, so there's a lot of cool stuff. You have to pay for that. Visualization of workflows, again, not a single pane of glass. I did talk about monitoring, logging, and metrics. This is something that if you're doing this completely on your own, well actually if you're doing it no matter what, you do need to think about how your data models look for, what your different labels and tags and things look like within your system, what your log messages and log formats and everything looks like, such that you can consolidate them and quickly identify this is in cluster A, that was in a cluster B in Europe or whatever. You need to be able to think about those things from a level up from just being just a regional area as well. There's also plenty of third-party apps and OS open source software that's out there that I didn't talk through these, and so those are other pieces. So last slide I have here, pretty sure. Yep. Last slide here is if you are going to go ahead and start doing this on your own, it's kind of up to you if you want to do this. It's a lot of extra work. I would say the Anthos product is actually pretty darn good. There's a lot of cool little things that are in there. And again, it's based on open source, but if you want to do it completely on your own, I would immediately start looking at adopting Istio for your traffic management. I think the service mesh is really cool. Look at Flux CD, it's done by Weaveworks. That's a really similar style system to what the Anthos configuration is. Then look at Knative if you really want to start pushing the serverless applications as well. So with that, this is my pretty slide. For those of you, there's a Nordhall people here. These are all of the different, not all of them, but these are a large amount of the different types of tools that we like to work with, kind of put together. So, any questions? It's time to drink beer.